Okay, so today is the 20th of November. This is the first day of Similar Polygons. So this is similar to what we've been doing with congruency, but it's a little bit different, and so we're going to use some different words. Our objective or our question today is, how do I determine, it's a T, determine if two polygons, that's a G, gons, are similar. So first, we have to decide what similar means. So think about what similar means in terms of real life. Like, similar means like. So that's not a good color. Two polygons are similar if and only if their corresponding angles are congruent and their corresponding, because I don't have enough room, corresponding sides are proportional. So let's look at some of the important words. Similar, corresponding, congruent, and proportional. So congruent, we know. That's the same measure. I don't know what that says. Same measure. Corresponding. That's matching. So the same location, the same position. Proportional, I want you to think ratio or fraction. Maybe scale factor. Might ring a bell. And then, we've used this before, the symbol means therefore. So that's just some stuff. Don't forget, you still have to do your questions even though I wrote all that stuff there. So notation, the notation's kind of special. We use this weird, like an enye, it's just the curved sign. And we say that, we read that as similar to. So when you see that symbol, it means that whatever's in front of it is similar, and that has a specific definition to whatever's after it. So here's some examples. So I have this weird shape. And I have this other one that looks kind of like it, but I don't know if they are proportional or similar. So this is 10 meters, 5 meters, 6 meters, and 8 meters. And then these angles have these symbols in them. This one has 3. Go with me on this. And then we have E, F, G, and H. And this is 5 meters, 2.5 meters, 3 meters, and 4 meters. So how do I figure out if they're similar? So we start with the similarity statement. A, B, C, D is similar to E, F, G, H. So what does that mean? That means that A needs to match E, that B needs to match F, that goes there, C matches G, and D matches H. That means that our congruent angles, angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. Up here it said the corresponding or matching angles had to be the same. So this one has 4 lines, this one has 3, 2, and 1. So you can see that A matches E, B matches F, C is the same as G, and D is H. So they're all congruent. Now I have to prove that their corresponding sides are proportional. So we're going to do that by saying I have to be able to prove that AB over EF has to be equal to BC over FG, has to be equal to CD over GH, needs to be equal to DA over HE. So when I plug those numbers in all the way across, AB, that's 5 over 2.5. BC is 6 over 3. CD is 8 over 2. And DA is 10 over 5. All of those equal 1/2. So they're all the same. So that's why what proportional means. They all have the same ratio. Okay, let's do a couple of examples. The first one starts with these 2 triangles. So first we start with our angles. So I just number these 1 and 2. So remember, we're going to do 1 thing for angles and 2 things for sides. So does angle A match angle D? Well, they're both 30. So the measure of angle A equals the measure of angle D. Therefore, angle A is congruent to angle D because of their measures being the same. And then angle C is congruent to angle F because they're both right angles, and we just did the right angle theorem. So that's right angle congruency theorem. And then angle B is congruent to angle E because of the third angle congruent theorem. Colored pencils make this much harder to do. So we have all of our angles congruent. So now we have to prove that our sides are congruent. So that's is AB over DE equal to BC over EF. Do you know where I'm going? AB, DE, BC, EF, and then we have to say, is it congruent to CA over FD? Remember that order is really important. So when I plug those in, AB, that's 12 over 9. That's BC is 6 over 4.5. And then we've got 6 square root of 3 over 4.5 square root of 3. This is ugly, but the calculators do this, so no freaking out. So this is 4/3 over 4/3 over 4/3. Those are all the same. Therefore, triangle ABC is similar to triangle DEF. So you have to be able to prove that all of the angles are congruent and the sides all have the same fraction or ratio or proportion. Okay? One more example and then we'll do some more. So let's start with this one. So the first step is what? To prove that the angles are all congruent. Are they? Well, they're all right angles, and we know that right angles are. So all angles congruent because right angle congruent theorem. So we know that, right? So then we got to look at our sides. Are the sides congruent? So I need AB over EF congruent to BC over FG has to be equal to CD over GH has to equal DA over HA. So then we go plug that in. AB is 7 over 6. BC is 6. FG is 5. There's already a problem there, but we're going to keep going. CD is 7 over 6. Okay, that takes us back here. And DA is 6 over 5. Well, they have to all be the same. And these aren't, and these aren't, and these aren't. So, the answer to our original question, are they proportional, is no, not proportional. Or not similar. That's the word I want to use. Scratch that. Similar. Okay? Because they're not even. Even though all the angles are, this is not a bigger version of this. Okay? All right, so make sure you have that, and then we'll turn it over.